DeepSeek-R1 was an important step in large language models because it was trained for a very specific goal, reasoning. This was done using a reinforcement learning method called Group Relative Policy Optimization or GRPO. Reinforcement learning itself is not new for language models. Models like GPT already use reinforcement learning through RLHF or reinforcement learning with human feedback. But DeepSeek-R1 uses reinforcement learning in a different way. GRPO is derived from proximal policy optimization or PPO. The key difference is that GRPO does not use a value function. There's no learned critic. Instead, everything is computed relative to a group of answers. Before training begins, we define a reference model. This model acts as an anchor. It represents safe and reasonable behavior. The model is allowed to improve, but it is not allowed to drift too far away from this reference. In DeepSeek-R1, the reference model is already strong at reasoning. The goal is to refine that ability, not to change the model's personality. Now here is how GRPO works. First, we take one prompt. For that same prompt, the model generates multiple different answers. These answers form a group. Next, each answer is given a reward. In DeepSeek-R1, this reward is not based on human preferences. It is task-based and verifiable. For example, is the math correct? Is the logic valid? Does the reasoning reach the right conclusion? Often, the reward is simple, correct or incorrect. After we compute rewards for all answers, we compute a relative advantage. We take the mean reward of the group as a baseline. Then we check where each answer lies relative to that mean. Answers better than average get a positive advantage. Answers worse than average get a negative advantage. This is why it is called group relative policy optimization. The model is not learning what is good in absolute terms. It is learning which reasoning paths are better than others for the same question. During the update, GRPO uses clipping, just like PPO. This prevents updates from becoming too large and keeps training stable. Finally, KL divergence penalty is applied between the current model and the reference model. This limits how far the model can drift. The model is allowed to explore, but only within safe boundaries.